So welcome back, guys. Today we're going to be looking at arithmetics with functions. So we have already did a lot of arithmetics ever since I'd say maybe even grade 2, grade 3, we were introduced to addition, subtraction, division, all of these arithmetics with regular numbers. And obviously we're pretty good at them. So let's up our game a little bit and let's go ahead and add and subtract some different functions. So that's going to raise our game by a lot. And then after these, we're going to see some combination of functions maybe a little bit later. Let's go ahead and just quickly get started on all of this. So let's see. Let's read. I'll give you a second to read this on your own, and then I'll read this together. Okay, a popular coffee house sells iced cappuccino for $4 and hot cappuccino for $3. The manager would like to predict the relationship between the outside temperature and the total daily revenue from each type of cappuccino sold. The manager discovers that every 1 degree Celsius increase in temperature leads to an increase in sales of cold drinks by 3 cups per day to a decrease in sales of hot drinks by 5 cups per day. And within this linear relationship, we're able to come out with two different functions. So the function f of x equals to 3x plus 10 can be used to model the number of iced cappuccinos sold, with x being the outside temperature. The function g of x equals to negative 5x plus 200 can be used to model the number of hot cappuccinos sold, with x also being the outside temperature. In both function, x represents the daily average outside temperature. In the first function, f of x represents the daily average number of iced cappuccinos sold. In the second function, g of x represents the daily average number of hot cappuccinos sold. So right off the bat, this tells us to make a table of value for each function with the temperature intervals of them from 0 to 40. Intervals of 5 degrees Celsius from 0 to 40. This is dumb work. This is just plugging numbers in our calculator and just writing it out. So I'll give you a second to pause the video and do it. Meanwhile, I'll also get our friend ChatGPT to do it for us because it's really easy. Okay, GPT has given us our first table. Perfect. Oh, that was only one. So let's go ahead and crop this. So we will have our first function f of x equals to 3x plus 10. So this should be our amount of iced cappuccino sold on average. So we have that, and now we will also have g of x. Let's go ahead and take g of x. Right here is g of x. So this is the average number of hot cappuccinos sold on a day based on the temperature. So we have our both of our table of values. So we got our table of values done, but we're not going to look at them yet because the question doesn't tell us to. Let's go ahead and move on to b. What does h of x equals to f of x plus g of x represent? So now we're adding it up. So we have this function h of x, and it's the sum of f of x plus g of x. So let's go ahead and look at what definition of f of x is. So f of x represents the daily average number of iced cappuccinos sold, while g of x represents the daily average number of hot cappuccinos sold. So when we add those together up, what does that mean? Well, that means the total amount of cappuccinos sold that day, both iced and hot. We're adding up the iced and hot numbers to get the total number. So we have this little function right here, very easy. We gotta simplify. Let's go ahead and simplify this, right? This should be really easy. You have done a lot of this. It's just collecting like terms. All right. So let me enlarge this. So h of x is equal to, well, obviously they just plugged in. So f of x equals 3x plus 10, and then g of x equals to negative 5x plus 200. So let's go ahead and simplify that. So plus 10. So this doesn't need any simplifying. We can take away the bracket. So plus minus 5x, so that's negative 5x, and then plus 200, that's fine. So overall, we will have negative 2x plus 210, right? We simplified it. We just have to combine the like terms. And this is b. No, this is c. I'll write down b as well. So h of x equals iced daily average number of iced cappuccinos sold plus daily average number of hot cappuccinos sold, and this is equal to total number of cappuccinos sold. Okay, go ahead and move on to part D. Make a table of values for the function in part C with the temperature in intervals of 5 degrees Celsius from 0 all the way to 40. How do the values compare with the values in each table we made in part A. And how do the domains of f of x, g of x, and h of x compare? So let's go ahead and get our. I hope you can do this on your own. We have the function already, so go ahead and try this on your own, and I will get our friend ChatGPT to go ahead and spit out our third table of values. You may pause the video. Okay, I hope you're done, and I have here our table of value from ChatGPT. Obviously, he's done a pretty good job. He's an AI. Should be able to do this pretty quick, and he's also pretty much compared it for us a little bit. So let's see. He has this. So ChatGPT is really smart. He gave us all these two combined into this one big three. So we will have temperature right here, and we'll have f of x here, g of x here, and h of x here. So we can see that for every temperature, for every random temperature within our interval, um, a f of x plus g of x. So basically, the value of h of x, f of x plus g of x is going to be equal to h of x. So we have 10 plus 200, so 210, 25 plus 175, 200, 40 plus 150, 190, so on and so forth. So this kind of matches our definition that we made. So and we can basically conclude that the values of h of x are the sums of the corresponding values of f of x and g of x. So for example, let's say h of 10. So h at degrees Celsius of 10, we will have 40 plus 150 equals to 190. And the domain of f of x, g of x, and h of x are all the same within this context. So the domain is 0 degrees less. So the domain, let me write that. Domain is, wow, x is all real number such that 0 is less and equal to x is less or equal to 40. Because this is the interval that they want us to plug in. Okay, so we compared our number a little bit. Let's move on to part E. What does h of x equals to f of x minus g of x represent? Well, it represents the difference, right? Because f of x is the daily number of iced cappuccinos sold. So h of x is equal to daily average number of iced cappuccinos sold minus daily average number of hot cappuccinos sold. This was equal to the difference. The difference. This will be equal to the difference between the daily average sales of iced cappuccinos and hot cappuccinos. Right? This will be the difference. So let's go on and move to f, which is basically another simplifying problem. So h of x is equal to 3x plus 10 minus negative 5x plus 200, right? So get rid of the bracket, 3x plus 10, negative, so plus 5x, and minus 200. So let's go ahead and do that. So this is going to equal to 8x minus 190. So right here we have our third function. So let's see. We want the table of value again, and let's see how this compares. So you could go ahead and pause the video real quick, and I want you to go ahead and write out the table of value on decimals or whatever, or your graphing calculator if you have one. Okay, perfect. Well, GPT has gave us our third table, right? Fourth table right here. So we can see this matches whatever we had with the addition, right? So we will see that no matter the temperature, and we'll have f of x and g of x right here, no matter what it is, it's always f of x minus g of x. So let's say at 0, it's 10 minus 200, so negative 190, 25 minus 175, negative 150. Okay, this all makes sense. This is adding up. This is good. And now the domain should still be the same. And the value of h of x is simply obtained by subtracting g of x from f of x. So we have the same domain. Now, let's go ahead and get into something more spicy. What does r of x equals to 4f of x plus 3g of x represent? Right? So call back. Our iced cappuccinos are $4 and our hot cappuccinos are $3. So therefore, 4 is our price and 3 is also our price. So these are basically our total revenue. So 4 times f of x is how much we make from our iced cappuccino every day, and 3 of g of x is how much we make from our hot cappuccinos every day. And after we all add that all up, that's our revenue function for the day, right? So r of x represents the total daily revenue from selling both types of cappuccino. And let's go ahead and write that down. So f skip g. So r of x represents our daily value of revenue from selling both types of cappuccino. Okay, let's go ahead and simplify this. So r of x is equal to, this should be not as hard, a lot easier than what you think. This is a lot, it's slightly harder than what we have before, but it's still very easy. So 12x plus 40 minus 15x plus 600. And that should simplify to negative 3x plus 640. Right? So this is our fourth function that we have that we're going to be investigating. So we're going to go ahead and plot another table of value for this. Let me just get rid of these real quick. Let's look at another table of value. Well, actually, I don't have to get rid of that. Let's just move this on the right. And let's go ahead and look at another table of value. So you can go ahead and use this function, get some table of value, same interval, same everything. Pause the video and do that. Okay, I hope you've done that on your own. We have gotten our function as well. So right here, wow, that's really big. So let's look at this. So this is our fifth table value that we have. So we look at this and we're like, okay, that makes sense. We're multiplying f of x by 4 plus 3 times g of x. So 40 plus 600. Okay, that makes sense. All of these are making sense. So the values of rx is basically just by calculating by 4 times f of x plus 3 times g of x. That seems really straightforward. And our domain should have no change because we plugged in the domain. So let's see. How does the temperature affect the daily revenue from cappuccino sold? So let's think about it. So what do we want to know? How does temperature affect the daily revenue? So we're going to be looking at the slope, right? So we're going to be looking at the slope. So for this equation, we'll have negative 3x plus 640. So what does this mean? So the slope is negative 3. Now let's interpret this slope. So what is our x value? Our x values is the number of degrees, the degrees Celsius, the temperature. So when we have one increase in x, we will have negative $3 lost. Well, we will have $3 lost. So basically, therefore, for every 1 degree Celsius increase in temperature, the daily revenue will decrease by 3. So let's go ahead and write that down. So based on our slope, we can conclude that for every degree Celsius increase in temperature, we will be losing $3 in revenue. Pretty straightforward, guys. So now, let's go ahead and look at something even harder. So L. Explain how the sum function h of x would be different if both f of x and g of x were increasing function. So we're jumping out of this scenario. We're jumping out of this entire iced coffee thing. Instead, we're going into an absolute theoretical and hypothetical example. So let's see. If f of x or g of x are both increasing function, what does that mean? So what are we trying to find out here? L. If both f of x and g of x are increasing function, and we add them together, that means we will have a function that is also increasing. H of x would also be an increasing function. If you think about this, let's say what's an increasing function? So y equals to x, that's an increasing function. Y equals to x plus 3, that's also an increasing function. When you add these together, you're going to have y equals 2x plus 3, right? It's still an increasing function. Now, what if both of them? So the sum would increase as x increase. B. If both f of x and g of x are decreasing functions, and we add them together, notice that when you have f of x minus g of x, even if g has positive terms, it will still turn to negative. So we would have then h of x would also be a decreasing function, and the sum would decrease as x increases. Now, what does the function k of x equals to g of x minus f of x represent? Is it the same graph? Is it identical to the graph h of x equals to um equals to sorry, f of x minus g of x? So let's go ahead and look at this. Let's think about this. Let's jump back into our cappuccino example. So let's say k of x. So m. Let's say k of x was hot cappuccinos minus cold iced cappuccinos, and h of x is iced cappuccinos minus hot cappuccinos. So what is k of x? So k of x is basically hot minus cold, right? Hot minus cold. So k of x would equal to, right here, k of x would equal to negative 5x plus 200 minus 3x plus 10. So k of x would equal to negative 8x plus 190. Now what about our h of x that we already got before, right? Well, we didn't get that, but anyways, h of x would be 8x minus 190. So we look at this. What can we see? What do we see? Well, it looks like this is h of x is equal to negative k of x. And then just a few lessons ago, we learned about reflections, transformations, everything. So what does this mean? This means that this is reflected about the x-axis. It's a vertical reflection, right? So we have this reflection, and this is the only different. So the graph will not be identical. Rather, it will be a reflection across the x-axis. Perfect. Let's go ahead and move on to n. Determine the function f of x equals to h of x equals to f of x multiplied by g of x. Does this function have any meaning in context of daily revenue from cappuccino sold? Explain how the table values from this function actually relate to the values that we made in part A. So let's go ahead and do that. So h of x is equal to 3x plus 10 negative 5x plus 200. So now we're multiplying them together. What would we have? We'll have a quadratic function, right? Obviously. So negative 15x squared plus 600x minus 50. Wow, why is it equal to sign? Okay, I'll just simplify 600 minus 50, so plus 550x. And 200, so plus 2000. So this is our function. And I want you to pause and make the same interval, just real quick. Make the same table values. Okay. Perfect. I hope you have done that on your own. GPT has also given us our graph, our table value right here. So let's observe. So this is quite similar to what we had before. It's basically just f of x multiplied by g of x. Now what we want to do is that let's see. Does this have any real meanings? What does this really mean? So when you multiply the number of iced or hot cappuccinos sold, it doesn't really mean anything. It doesn't represent revenue. It doesn't represent anything. So it's just the product. That's it. So this new function represents nothing but the product. It has a theoretical meaning, but it does not have a real. It has a theoretical value, but it doesn't have a real meaning. Okay, and finally, let's look at our if you're given the graph of two functions, explain how you could create a graph that represents the sum of the two functions. So when we have the sum of the two functions, and after we observed everything, when we have the sum of the two functions, it's really the sum of the two function values. So so we can draw we can so we can draw another graph by obtaining key points. And each key point is simply adding up the y values for each corresponding x values. It's as simple as it is. It's as simple as it sounds. All we have to do is just add it up. That's it. We just have to add up the corresponding x values. And it's the same thing for B. The difference, B. We can draw another graph by getting key points. And we simply subtract the y value, the y value, the y value of the first function, of the second function from the first function. Second function from the first function to at the corresponding x values. It's as simple as it sounds. It's very simple. Hopefully we get a chance to do it soon. There should be an example. Anyways, C. The product of two products. This product of two functions. So for each x value, just multiply the y values to get the product and sketch with key points. Okay, and that is it for our lesson. Hopefully you got a good understanding on what we can do with functions and all of these addition and arithmetics, and I hope you guys have a great day. Oh, I forgot to give you my summary. That's what we've forgotten today. So here is our summary. So if two functions have domains that overlap, they could be added, subtracted, or multiplied to create a completely new function on the shared domain. And what we need to know is that two functions can be added, subtracted, or multiplied graphically by adding, subtracting, or multiplying the values of the dependent variable for identical values of the independent variable. Two functions can be added, subtracted, or multiplied algebraically by adding, subtracting, or multiplying the expressions for the dependent variable and then simplifying. The properties of each original function have an impact on the properties of the new function and likely will carry over. And of course, I cannot forget to give you guys homework. So there's homework on your textbook, page 56, 57, and 56, 56, 57. There will be 8 questions in total, and I suggest you doing all of them because this is a rather new topic, and we will have a chapter 1 review and practice session next lesson. Thank you guys.